Hey guys, today I want to talk to you about translating graphs. I remember translating graphs, what it means by the little SL in here. It sounds like they're sliding, and that's exactly what we're going to do with them. Now, this is probably one of the funnest, easiest lessons ever, because all you need to do is remember codes. You guys know codes just like phone numbers, and you already know linear graphs appear to be straight lines, and the code is f of x equals x or y equals x. That's how you would get the graph. Exponential functions, we had to look at growth or decay. If it was a number larger than 1, I just chose 2. Then it looked like this, it went up. If it was a decay, it was a number smaller than 1, then it took the curve down. Absolute value is a new one. But remember, absolute value is a lot like linear. It's just that it won't allow the negatives to come out as negative. The y keeps it positive because these absolutes are on the x. So when we plug in an x value, it'll turn it positive unless we do some funky stuff to it. So the absolute value function looks like a v. That's easy to remember with the v there. A student told me that one time. That's how he always remembered. Absolute value is a v with the v right there. Now there is another one that's just a preview for a later chapter, but we've mentioned it a little bit as we've been going through the sequences, so I want to keep bringing it up. Quadratic, that's when the x is squared. And what happens there, it looks quite a bit like our exponential because it does have an exponent. But when you plug in your x value, it squares it. Well, when you square a negative, it turns positive. So if you have these two to graph, make sure this one is obvious to me that it's a V, a point, and this one is a rounded U shape. And we'll get into actually squaring those numbers so it looks that way. We call these parent functions because if we put no other numbers in them, this is how they appear on the graph. And it's like proud parents. Your parents look at you guys and they go, oh, he's got my eyes. Oh, she's got my smile. They get all goo-goo about it, and it's just like that with the graphs. When I look at these, I go, oh, that's a linear function. It looks just like the mama. You know, that, okay, that's enough. So moving on. Here's the code that will really help you if you'll get this in your notes. We're not going to get into transformations, so I'm not going to talk about the plus or the minus out front. Just going to talk, and not about the a value in the front, just going to talk about your h. Shift to the left. If it's a negative h you plug in there, then what happens, it's so cool you guys, is if I plug a negative h into this code, then what happens is it becomes a positive, but it moves that parent graph left. If I plug in a positive h, it looks like it's negative and moves it right. So this little area in here, I always just think it's backwards. It's like the secret area, like you can't quite see in there, so it's like, ooh, if it looks left, it's going to go right. If it looks right, it's going to go left. On the outside of that are numbers here for the k value, and that will shift a graph up or down. So the other thing that I wanted to mention is right here we have the linear, because we do not have x raised to any higher value, so that would create a straight line. It's all about what these are doing that creates the shape. Now, if we change this slightly, and I'm trying to be color-coded, it's way too cool. If we changed it slightly, and we had the parentheses here, but we raised it to a 2, then you would know, oh, I'm going with the graph right here. And I'll be honest, I shift right, left, or up, down off of this vertex. Off of the vertex right in the middle of the graph where it would normally be. Now let's say we don't do quadratic, and instead we want to do absolute value, that V shape. the V shape. We would have the absolute value sign in there, and then we would get a V shape, and we would be moving this point left or right, up or down. So the only other one that I didn't go through was the exponential. Let me do that real fast. On exponential, it is slightly different. Write this in your notes, because we have to have the exponent. The A value would still be out front here, but then you have that 2 if it's a growth. If it's a decay, it would just be a half. I'm not going to show you decay as well. And then you would raise it x minus h. The h is always going up with the x. So if it's a minus number, then you know that it's going to go right. If it's a plus and then a number, then you know it's going to go left. Because how we plug it in there, that negative actually switches it around so it looks different. Now, let me just grab super fast my graph board, because I forgot it. So sorry about that. So, I just wanted to show you a couple. So like when you come into class, we're actually going to do aerobics and play around with these, move around the room some. But if I give you y equals x minus 4 plus 2, you would think, absolute value. Parent function looks like this. Boom, boom. There he is. That's my vertex. I'm going to move 4 to the, go back to your code. I said, if it's a negative h in the equation, that's actually a positive h that was plugged in, so it's going to go right 4. And then the k is plus 2, so it'll go up 2. So you take this vertex here, you go right 4, 1, 2, 3, 4, up 2, and there's the baby. He looks just like that. Okay? So then I might give you a different one. I might say, oh, let's do linear. Let's go y equals x plus 10, whoops, linear, minus 5. So linear is a little bit harder to see, but the parent function went like this. So I would go plus 10, which would be, which way? Opposite than how it looks when it's in there. So it's 10 to the left, minus 5. And there's little baby. He looks just like mom and dad, but he's located over here. Okay, let's get one more up here because this is just looking way too cool. I dropped my brown pen. Oh, well, you're going to have to forgive me. We're going to put it in purple. Y equals 2x minus 3 plus 1. So now that is an exponential. Whoops, that plus 1 shouldn't be up there. Plus 1, that's the k value. That's exponential. The h is always with the x. So normally the parent is a growth. So he would have looked like that. But now his little baby, he moved 3 to the right. I take again this vertex right at 0, 1. And I go 1, 2, 3 to the right. And up 1. So he's going to go right through there. And then I just draw that graph again. Now these get tricky. Because remember I told you guys about the asymptotes? That line that you should have highlighted when we were talking exponential sequences and functions. Remember, they won't touch the asymptotes. So, when you move this one up, you should move an asymptote line with it showing it's never going to cross that asymptote now that's at 1 because he moved up. Okay? Let me think, what's another one? We did vertex, or absolute value, exponential, linear, quadratic. Let's do one with quadratic. Let's see the poor quadratic that he got moved down. He didn't act like his parents in regards to plus 5 squared minus 10. Okay, so remember his parent. It's that U shape coming right here. And you really should think about this. The parent one at 0 squared is 0, 1 squared is 1, 2 squared is 4, so that helps you to form the U. Now, when we move him, he goes 5 to the left. 1, 2, 3, 4, 5. And he's down 10. You should be counting it from here. He's down 10, so it'd be right there. He goes 1 squared is 1. And then he goes over 2. 2 squared is 4. And that gives you the just of the U shape if you get 5 points there. Okay, so basically today we're just looking at how these things move by that code. Make sure that you have this in your notes, the code. Make sure you have this in your notes, the different shapes. We're going to have fun with this. See you in class.